Hello everybody, welcome back to the GOLCS Legacy remote learning platform. Today we're going to be working on the 5th grade Unit 8 Lesson 13 packet. You can follow along in your packet. I think about it says, use the decimal grids provided or any other tool to determine each product. Here in this column you can see our scaling goal, 1/10 of 2. And in this section you can see our problems, and then the grids are provided for us to help solve these problems. So problem number 1 says, what's 1/10 times 2? And we're going to use our grids to help us solve these problems. Each grid is divided into 10 sections. So you can see I shaded in one of the sections because that represents 1/10. So here we have 1/10 and here we have 1/10. And so what is 1/10 times 2? You will see that it is 20 hundredths, or 0.2. So that's for number 1. We'll look at the second one, 1 times as much as 2. So like I said, each grid is broken up into 10 pieces. So if we're talking about one whole, we want 10 out of 10. That would be the entire grid here, because that's 10 out of 10 pieces. And then we want to multiply by 2. So that would be the entire grid here, which is 10 out of 10 pieces. So, I mean, I'm sure you all already know this, but we just modeled it with our grids here. But 1 times 2 is indeed 2. And then for problem number 3, we have 1 1/10 times as much as 2. So we have 1 whole and 1/10, and then we want to make 2 of those. So like in our previous example, we know that 10 out of 10 pieces is 1 whole. So we're going to shade this whole thing in here. That's 1 whole, but we also need 1/10 out of this section. So we have 1 1/10 here. And we also need, since we're multiplying by 2, another 1 1/10. So 10 out of 10 is 1 whole. So we have 1 whole here. And then we have 1/10 here. So together we have 1 1/10 plus 1 1/10 is 2, or 2.2. 2 2/10. So those are the answers for these first 3 problems. I want you to take a minute and try to solve this, the open-ended portion here that says, in the problems above, the number 2 is being scaled. And in this case, that just means making larger or smaller. When will the product be less than 2? And when will the product be more than 2? Explain your answer. So they're asking for 2 answers here. When will it be less than 2, and when will it be more than 2? Well, let's look back at our model to try to help us out. So the number 2 is being scaled, and sometimes the answer is going to be less than 2, sometimes it's going to be greater than 2, and actually where I want to start at is in the middle, where it actually is 2. So when 2 is scaled by a factor of 1, we see that it's actually the same amount. In problem number 1, we see that when 2 is scaled by a factor of 1/10, our number is less than 2. Our product, rather, is less than 2. And then we see in problem number 3 that when 2 is scaled by a factor of 1 whole number and a decimal fraction, 1.1 in this case, we see that our product is greater than 2. So that pattern tells us that when we scale a number by 1, it stays the same. And we knew that already. We know that 1 times any number is going to give us that same number. But what we just learned by following this pattern is when we scale a number by a factor greater than 1, by a factor, our product is what? So this factor is greater than 1, and we saw that our product is indeed larger. And then finally, our pattern from the first problem, when we scale by a factor smaller than 1, our product is smaller. So based off of what we've done in the first part of our problem, this is what we see to be true. On the next page, we're going to form our conjecture, and then we're going to test that conjecture to see if it's true or not. And then hopefully we can get some new discoveries going on here. So thinking about what we learned on our think about it, is this number going to be larger than 1 or smaller than 1? Yeah, I agree. So if our product is going to be greater than 2100ths, then that means that this number has to be larger than 1. So it has to be 1.021. Because this number is larger than 1, which means our product is going to be greater than the number we started with. And that only leaves us with one option left, but let's just talk this one through. 8 400ths times some number is going to be less than 8 400ths. So we can see that our product is going to get smaller because it's going to be less than 8 400ths, which means the factor that we're multiplying by has to be, yes, less than 1. Which, although close, 989 thousandths is still less than 1, right? So these are the correct answers, and we can see what was true in our think about it is also true here for test of conjecture number 1. Now let's look at test of conjecture number 2. Will the product, I'm going to just highlight that because that means multiplication. We know that means to multiply. So will the product of 19 4/10 times 200ths be more than, less than, or equal to 19 4/10? How do you know? And the how do you know is really the important part, because if you can prove that you know, then you really understand the contents of this lesson. So more than, less than, or equal to. So we know that 19 4/10 times 1 is going to give me 19 4/10, right? So we know that it's not going to be equal to, because that's not a 1. That's a rule we already know. So it's not equal to, right? Now, thinking about what we've done here and what we've done in the think about it, is this factor greater than 1 or less than 1? Correct. It's less than 1. Now, look at what we did in this problem as an example. When we multiply by a factor less than 1, as in example C, we saw that our answer decreased, right? So now we're multiplying by a factor that's less than 1 again, which is going to tell us that our answer must be what? Indeed, less than 19 4/10. So my sentence is going to be the product of 19 4/10 times 200ths will be less than 19 4/10. I know this because when multiplying by a factor less than 1, our product will always be what? Greater than the number we started with, equal to the number we started with, or less than the number we started with. Exactly. Will always be less than the number we started with. Great, and that's the correct answer. So remember that when we're multiplying by 1, we'll always have the number we started with. If we're multiplying by a factor greater than 1, our product will be larger, and if we're multiplying by a factor less than 1, our product will be smaller, right? And so this has to do with scaling, and we're gonna use this from 5th grade, 6th grade, 7th grade, all the way up in mathematics, so we really need to understand this concept. So I'm gonna give you our conjecture for today, and then we're gonna go review TTC number 1 and TTC number 2, and see if our conjecture held true or not. So our conjecture says that scaling by a factor less than 1 makes a smaller product, and scaling by a factor greater than 1 will make our product larger. So let's just review these two problems really quickly and see if this conjecture held true. So we're gonna skip out letter A right now for this, but we'll come back to it. In letter B, we see that we scaled by a factor greater than 1. 1 and 2/100ths is indeed greater than 1. And we saw that our product here was greater than the number we started with. So it did hold true for example letter B. Now let's look at example letter C. Here we multiply 8 and 4/100ths by a factor that is less than 1, and we see that our answer is indeed less than the number we started with. So we started with 8 and 4/100ths, and we see that our answer is going to be less than 8 and 4/100ths because our factor is less than 1. So our conjecture did hold true for TTC number 1. Now looking at TTC number 2, here we started with 19 and 4/10ths, and we scaled by a factor of a number that is less than 1. Now if our conjecture holds true, then that means that our product should also be less than 1. Also less than the number we started with. And as in our description, you can see the product of 19 and 4/10ths times 2/100ths will be less than 19 and 4/10ths. So our conjecture did hold true for TTC number 2 as well. And indeed, our conjecture is true. When we're scaling by a factor less than 1, we'll get a smaller product all the time. And when we scale by a factor greater than 1, we'll always get a larger product. And then you guys already knew that when we scale by a factor of 1, we'll always get the number that we started with. Thanks for hanging out. Looking forward to connecting with you guys on the next lesson. If you have any questions, please be sure to leave them down in the comments. Talk to you soon. Bye-bye.